Then when I started again to train my athlete in speed skating, so the slow motion would be a useful tool also for speed skating. So I started working on it. This is what I found. So this is a video from a recent training camp we made in Renegade with my team and a couple of other teams. And as you can see, slow motion is I hope everyone already knows how slow motion is, but it just allows us um, to film our athlete and see how they move in a deeper way, because sometimes we see our athlete moving fast, and to focus on some little details is hard. There are great coaches there. They are very good at correcting technique and see what it's not efficient in our athlete, but try to objectify everything can help everyone to make a better job. If we want to use video analysis, is the only way that allows us to work with our athletes and make them aware of their mistakes or their area of improvement. So it's good to give feedback to the athlete, but sometimes it's good that they can see themselves performing, and recording them is good. But as I said before, a good coach maybe can spot the mistakes at normal speed, but for athlete, maybe just focusing on a couple of frames can help them be more aware of their area of improvement. So how you can do it? You just need a camera or a smartphone. Actually, smartphones are cheaper. Everyone has it. If you got an updated one, you can do it your analysis on your own. You just need a video that goes at least 2000 to 140 frame per second, and in high definition. We will see later why. But actually, if we want to spot everything and do our measurement, you need a high definition and be pretty close to the athlete. Otherwise, you won't be able to see everything. And of course, you need a huge storage, because video analysis and slow motion requires a lot of frames. You have to make sure you got, when you do a video, you got the space to store it. And this is the first option. Then there is another setup you can use, which I've used for the previous video you've seen, which is adding a stabilizer to your camera or your phone. This allows you to stay perfectly square to the athlete throughout the movement. It allows to add some parameters we will see and we cover later. The first setup requires you just to place your camera or your phone at 10 meters, I'd say, maximum 50 meters from your athlete, from the horizontal plane your athlete is running, and then record. Make sure that you are recording the entire starting sequence from the start to the finish, and make sure the athlete is in the frame throughout the starting sequence, of course. Lastly, make sure to start the video at least 3 seconds before the starting signal, because sometimes there are some softwares that requires a couple of frames for starting their slowing down the video. And the second option is addiction of the gimbal, as we have seen before. It is tricky because you have to follow the athlete and they start from a standing start. What I try to do is just basically to skate along with the skater. Of course, you need to be extremely precise when it comes to the start, because you are rolling and passing your athlete while you start from a standing start. So it's a little bit tricky from a practitioner standpoint, but it gives us some very useful insights. So maybe if you can find a better mechanism to follow your athlete, maybe to make it easier and not just skating along with him, it can be a good help. Of course, this last setup requires you to put some markers. You can see them here on the bottom, these red markers, and you have to know at what distance they are, because you require it to have some distance parameters when you do your analysis after the recording. This is what you get. We start from the top. You got, of course, your race time. Of course, if we talk about start, you need if you want to be precise, you need timing gates or something automatic. If you use your stopwatch for your 10 or 20 meters race, it's not that useful maybe or that precise. And if you want to maybe do some correlation after, you require extremely precise devices. Then we can do some static technique consideration from a technical standpoint. We can see if your athlete is starting with a lateral frontal start and compare it with the other athlete. If he's moving first foot first or second foot first, and stuff like that. And then we can start working on the video, count the number of steps from the start to the finish, or maybe we can just decide that we want to focus on the first 10 steps, which are the more correlated with the final 100-meter times. You can say just I want to see how far and in how much time requires you to do your first 10 steps. From here, we can find mean step frequency, so the number of steps each second. You can do it with a simple computation. If you want the mean step frequency, if you want single step frequency for a single step, you require a software and a post video analysis. Then we have partial step frequency, so maybe you can divide your 100 meters into first 10 meters, then 30 meters, and everything you want, and then compare again your athlete against other athlete or top-notch athlete. Then we can have the mean step length, which is the easiest way to do it is just to divide the race distance by the number of steps. If we want to have a single step length, so the step length, the precise step length for each step, we got two options. The first one is have a very good camera, so that allows you to record your video from a farther distance. So it allows you to maybe take all the 10 steps in one frame, and then it's easy to see how long is every step is. But you need to have a very good camera. A smartphone in this case is not good enough, so you need a professional camera. Otherwise, you can make, of course, some rough step length measurement, but not very very precise. But if you do the second option, okay, the second setup if you add the gimbal, you can stay closer to the athlete and follow him, and so you can see every detail of their pushing. Then we got the flight time, which is the time between the back leg leave the ground and the first frame in which the first wheel of the opposite skate touches the ground. So it's basically the time that our athlete spent on air. And then we got ground contact time, which is the time spent by our athlete, but this time on the ground and on air. So from the contact time to the time the skate leave the ground. The latent time is something I've developed, and is basically the time elapsed between the first frame your first wheel touches the ground and the time in which all the wheel of the same skate touches the ground, which is the time in which we have stopped pushing with the back leg, but we haven't started to push with the front leg already. It can be positive or negative. If we contact the ground with the first wheel first or the back wheel first, it's different, and we can make some consideration about it. Finally, you can have biomechanical parameters. So basically, you can see how your trunk is leaning forward, so the inclination of your trunk or every segment of your body when you're pushing, or look at your articular joint angles and displacement during the start. So this is everything you can take from video analysis. And this is what we can provide you with. This is an analysis I've done with data from Vincenzo Mallorca in 2023, the World Championship, when he managed to win the world title. When you purchase your slow motion video analysis in our website and you send us your video, we do the analysis and you will be provided with a similar report, basically the same report with your data. As you can see on On the first page, we got race time. This is taken from the official results, basically, and is compared with the best results of other athlete. For that year, he was the fastest, or the best time, the time of the best skater, the average time of the best skater, of course, was slower than did how he skated. Then we can compare your static technique with other athlete, and then we can start looking at the number of pushes, okay, for the entire race, and we can see just from here you can see that Vincenzo managed to cover the distance with 2 steps less compared to the average of the senior man skater for that championship. On the left side, you can see the frequency. Again, we can see this time we can see that the frequency was slightly lower, of course, because he covered the same distance with a very similar time, but with less steps. So his strategy is maybe to pivot on his height. So he managed to cover the same distance with less steps and a slightly lower frequency. Step length, the same can be said here. Of course, he managed to do 20, on average, 20 centimeters more with every step than the other skaters. And then we got the flight time, which is the time spent on the air. I've done some correlation with this parameter, and from them, I can say that during the first 10 steps, it's better to have shortest possible flight time, because the time you spend in the air, it's maybe good when you are rolling as fast speed, but during a start is more similar to running. So the time you spend on the air is basically time you are not pushing, and you want to be always in push. And as you can see here, this is probably the secret behind the great performances of Vincenzo, who managed to be very low with the skates on the air and spend less time as possible on the air, and just focusing on pushing, on continuing in pushing. Then we got the latent time we talked before. As you can see, it's pretty similar from skater to skater. If you maybe try to do longer steps, the latent time increase, but with the high level athlete, they are pretty much consistent and close each other with the time they spend between the first wheel touches the ground and all the width of the skate touches the ground. And the ground contact time is another interesting parameter. Maybe the most interesting one, which can be calculated only with a slow motion video. As you can see here, the first steps are fast, of course. It's a short ground contact time, but then it starts to get faster during from the third step, and then you can see it rises a little bit throughout the race. As you can see here, Vincenzo was spending more time on the ground compared to other skaters. And from all this data, we'll provide you with a report, technical comment, some consideration done by our staff that you can use to have a look on a more in-depth detail on your technique and work on it. And then we can suggest you some speed skating data options you can have to work on area of improvement that we highlight on the analysis. In this case, for example, online coaching could be an option to be followed by the speed skating data team, but Vincenzo has a good coach, so maybe we highlighted that it was not slow, but slower than the average skater on the ground. So maybe working on his ground contact time would be the last thing he can work on to improve his performance. And so maybe in that case, just purchasing this is a program we have already developed. It's not on the site yet, but you will find it shortly, which is basically a training program designed to work on ground contact time and how to make it faster. Of course, the interesting side of this project is that we can work on more athlete, and the more athlete we manage to insert in our database, and we can maybe focus on just youth athlete, junior athlete, and say you can compare your performance to the skater the same age. In the future, hopefully, we can work with truck manufacturers and design speed skating facilities that allows us to integrate the slow motion analysis during training or even races, which will be very interesting. The other thing we can focus on is to try to apply slow motion analysis to other settings, so maybe corner or straight technique. It's very hard to do, but we can work on it, and we can help you integrate the video analysis. The option you got with the Speed Skating Data Project is to do your own video and send us, and then we can do the analysis for you and send the report. The other option is if you want us to come over your training facilities, just ask us. We can schedule a time. Maybe you can invite 20, 30 athletes at the same time. We can do the analysis and then do it 2, 3 times during the year, and then see how are you working. And then, of course, we can help you once you got the result to make you faster.